Hello and welcome to BISP Solutions. My name is Ankita and today we will continue with the Calculation Manager business rules. Today we are going to learn three new topics or we can say that today we will learn three new business rules. So first one is the employee tenure calculation, second one is the compensation and benefit calculation, and the third one is the block creation okay. So now we will start with the employee tenure calculation first. Okay. So before that, I would first like to show you the requirement. So here in the given sheet, we can see that here we are calculating the tenure of the employee in an organization named John Patrick, who is working as a sales director. Okay. So here we can see that the John Patrick started its job from 1st of January 2021 and he's been working days per month is 22 days. Okay. So action here we have is the active, which means that the employee is still working in an organization. So this was availed by use of the drop down key as the member name action is attached with the smart list that I will show you in detail how we have been working on it. Then on that basis, we have calculated the employee tenure. So here we can see that the employee tenure is 32, which means from 1st January 2021, we have considered 12 months. Then for financial year 22, we have considered 12 months as well. And we have considered 8 months till the date, till today. Okay, so by totaling all these numbers, we will get 32 as the employee tenure. Okay, so now we will move forward to the business rule writing. So for that, I will go to the instance first. Okay, here now I'm going to click on navigator and then I will click on rules here. Here I will also open dimensions to show you the smart list that is being being added as a data type in action member. So action is the member in the account dimension. Wait a minute. Let me first select the cube here, then action. Okay, so here we can see that the member name is OWP underscore action. I will click on edit. And here we can see that the data type here is a smart list, and in this smart list OWP underscore status named smart list is being attached. Okay, so let me take you to the smart list where it is being added and I will show you the members in it. So for that I will click on a smart list first. Here I am going to search for the status. OWP underscore status. So here we can see that the entries in this smart list is first one is active, second is departed, third is disability, fourth is leave of absence, fifth is maternity, sixth is on sabbatical, seventh is transfer out, eighth is transfer in, ninth is resigned, and 10th is closed member. Okay, so here we have the ID numbers in front of each members. So for active member, we can use ID number as a substitute while writing the rule. Okay, So now I will go to the calculation manager and I will select the cube in which I'm going to write the rule. Okay, so here I have selected OEP WFP and I will right click on the rule and then select new. Then here I will name it as employee tenure test. Okay, we are going to edit the rule in the edit script mode. I think there is some issue because of the speed of the connectivity. So let me first close it and then again I will reopen it. Okay, so I will again go to navigator and then to the rules. And then I will click on OEP and here I will click on the rules. Okay, so here I am going to select the rule that I have recently created. Then I will click on edit script mode. Okay, so here now I'm going to first fix the member OEP in parentheses. I'm going to fix the member OEP underscore plan, which is a member of scenario dimension. Then OEP underscore working, which is a member of version dimension. Then the currency is going to be USD. Then here I want to fix the property, so here I will be naming it as no property. And then I will fix no project. Okay, now I'm going to fix the year as FY23 and FY26. So here I have selected the range of period, range of year, that is from FY23 to FY26. Okay, here it is going to be end fix. Then here I'm again using a nested fix function, and here I will fix the year total, which is period. So here I'm going to use the relative function to fix the period. Year total and then comma and the zero level members. Okay, after that again I'm going to use the use descendant functions. Descendants for fixing the entity named US. Okay, after fixing it, I'm going to write the end fix statement over here. Okay, now after that we are going to use the if function. So for that I'm going to name the member block as employee tenure. Okay, so that I will first go to the instance here, then to the dimension, and here I'm going to select the cube, and here I'm going to select the member, from the employee properties. Okay, so here we have the member named employee underscore tenure, and its alias name is employee tenure, so we can directly mention the alias name. Okay, after that I'm going to, okay, now I have added a parenthesis, open parenthesis, then here I am going to write the if function. So after if, I'm going to give this give the condition here. So the condition is going to be action double is equals to 1. As I showed you previously, the employee was active over here. Okay, action was active, and in the smart list the ID of active was 1, so we can directly mention the ID number as well. After that I will again mention the employee tenure. I'll copy it from here, then this is going to be is equals to, okay, here we are going to use a function named @calc manager month difference. Okay, so so this is the function we are going to use, which returns month between the 2 days, and the date is basically presented as year, then month, and then date for month. Okay, so in this case here we are going to mention the from date. Okay, so in the given case we have seen that the employee has joined the company from 1st of January 2021, so we will be mentioning the date here as 2021. So let me first copy this the function first to avoid the error. Okay, after that here I'm going to mention the parenthesis, and the starting date is going to be 2021 0101. Okay, and here I will be using another parenthesis, and there, okay, after comma, here we can see that from date to date is mentioned, so I have already mentioned from the date. Okay, so to date, here I want to calculate the employee tenure till today. Okay, so for that I'm going to use here the calc manager get current date. Okay, so instead of to date I will be going to use this function instead. So after comma I will write the function here. Here I don't need to mention any date, okay, as it will itself pick the date. After that parenthesis close, and then semicolon. After that I'm going to use here the else function, and then the employee tenure is equal to hashtag missing. Okay, it means if this formula runs, if this condition runs and we got the output, okay, if not, then the employee tenure will be equal to hashtag missing. Okay, So here we will be writing and if. Okay, now parenthesis close, which we have opened while creating the member block. Let me now validate the sheet here, business rule first. Okay, now my business rule is validated without any error. After validating, I'll deploy it and then I'm going to launch the rule. Okay, now I'm going to have a smart view connection in the calculation sheet. Okay, now we can see that the employee tenure here is 32 months. Okay, the system has already calculated it, and here we can see that the employee tenure, there is no variation in the employee tenure, hence our data is validated for employee tenure rule. Okay, now we will move to our next requirement, which is the compensation and benefit calculation. Okay, so in the given case, we can see that we are calculating the salary for an employee. So here we have the basic salary, which is 5800 member number. Then we have the car allowances, okay. Then accommodation allowance, responsibility allowance, medical coverage, staff provident fund, and payroll taxes are all being calculated. So the calculation is made on the basis of the basic salary, which is 5800. So here we can see that the car allowance is being calculated at the rate of 5% of basic salary. Okay. Okay. Here I will be directly mentioning it as 5% of basic salary. Okay. So how it is being calculated, I'll show you. Here basic salary is multiplied with the 5%. Okay, so we got the output as car allowances. Then now we will move to the accommodation allowance. So here the accommodation allowance is being calculated at the rate of 10% of the basic salary. 10% of the basic pay, or we can say that the member name is 5800. Okay, now I'm going to calculate the 10% of the basic pay here. So 5000 multiplied by 10%. So we'll be getting 5000. Okay. Similarly, we will be calculating the accommodation allowance, which is again 5% of, which is again 5% of 10%. Okay. So here it is 5. Okay. Now we are going to calculate the medical coverage. So the medical coverage here is being calculated at the rate of 15% on the total of basic plus car allowances plus accommodation allowances and responsibility allowances. Okay, so here we're going to 15% of basic, comma, car allowance, comma, accommodation allowance, comma, responsibility allowance. Okay, so now we are going to calculate that and show you how it is being calculated here. So here we are going to use the sum function, and I will taking the sum of these numbers from salary to responsibility allowance, then it will be multiplied with 15%, and we got the desired result as 9,375. Then now we are going to calculate the staff provident fund, which is being calculated on the basic pay, car allowance, accommodation allowance, responsibility allowance, and medical coverage at the rate of 12%. So it is going to be 12% of basic, car, accommodation allowance, comma, responsibility allowance, and lastly medical coverage. Okay, so now we are going to use the sum function again for the same, which will be from salaries to the medical coverage, and this will be multiplied with the 12%, and hence we will get 8,625 here. Finally, we will be calculating the payroll tax, which is the member name 6110. So this will be calculated on the basic pay, car allowance, accommodation allowance, responsibility allowance, provident staff provident fund. It does not include the medical coverage. Okay, and this will be calculated at the rate of 20%, which is according to their slab. Okay, so 20% of basic, car, accommodation, responsibility allowance, staff PF. Okay, so now here again we are going to use the sum function for salary, car allowance, accommodation, responsibility. Okay, so this will be used, then after that I will be using plus staff provident fund. I will be then adding it back, and then this all will be covered in a parenthesis and then multiplied with the 20% here. Okay, so we got the payroll taxes. So this is how we calculate the entire salary of an employee and its taxes. Okay, now we will go to the calculation manager in the application. Okay, now I will go to navigator and then to the rules, and we are going to write rule to calculate the salary calculation, salary and compensation. So this we are going to write in plan 1 Q, and here I will right click on the rules and then new. I will name it as compensation calc test. Okay, now I will click on OK over here. Here I am going to write a rule in the edit script mode. Okay, so by default we can see that our base data, which is an HSP view member, is already fixed. Now here I'm going to use a nested fixed function to fix the other members from the other dimensions. So while writing the rule, we always need to take care of the indentation. Okay, so here we will be fixing working, which is a version member, then plan, which is scenario. Then here I'm going to use @ descendant function to fix the year total. Okay, so here, which is a part of period, and this will include all the months from January to December and all the 4 quarters. Okay, then here I'm going to fix the product as P_000, which means no product. And then I will write here end fix. And I'm going to use an nested fix function, and I'm going to fix here the. Okay, so sorry, we're not going to use here the nested fix. Now I'm going to use here the if function. Okay, so for that I'm going to first create a member block with the name 5800, which is the salary. Okay, so I will first go to the application here into the dimension, and I will directly copy the member name from the dimension to avoid any error. Okay, so here it is going to be 5800. Okay, so here we have the member 5800. You're going to copy its alias name. Okay, so we are mentioning it in double quote. After that, I'm going to open a parenthesis over here. Then in the next line, I'm going to use the if statement. So here I'm going to use the member. With member, I'm going to use @isMember if the FY is 24. Okay. Okay, it is going to be FY 23. So this so one need to satisfy this condition, that is, if this business rule only takes place when the financial year is FY 23. Okay, here another nested if function is being used. So it is going to be @isMember. It is going to be 110, comma. Okay, let me do one thing. Let me copy directly from the application the member name. So these are the entities named 110, 111, and 112. So I will directly mention the name of the. Okay, so facility resources is 110. Then 111 is West Region Resources. Comma, the third condition is the East Region Resources. Okay, so here we have used the nested if function. So I will be mentioning it as and if here, and if, and then parenthesis close. Okay, so here in this line I'm going to write the formula. So my first formula is going to be car allowances calculation. So for that I will then again go to the account dimension. I will just mention here car. Okay, so here we are, car allowances. I will copy the member name, car allowances. Okay, after that it will be is equals to salary which is our basic salary, multiplied with the variable that we have created named car allowances. Okay, so here we have car allowances percent, and the default value that we have picked here is 5%. Okay, after that I will click on OK. So the variable that we have created, we can see, is mentioned in a curly bracket. So all the variables will be available to us in the curly bracket itself. Then after car allowances, we will be having accommodation allowances. I will copy the name here. Then is equals to, here I am going to mention the name of the member, that is basic salary. This will be multiplied with the accommodation allowance. So here I am selecting the variable name accommodation allowance. Here we can see that in the bottommost we can see that there is no value, there is no value available to us in front of the value member. It means we have to give the value while launching and deploying the rule. After that, after accommodation allowance, I'm going to mention the responsibility allowance here. Okay, so I will copy it, this responsibility allowance. Then the basic salary is being mentioned here. I will copy the member. And then it will be multiplied with the variable that we have created for responsibility allowances. Okay, so here I am copying it. In the previous session, I have already explained how we create a user variable into the application. Okay, so that is why I'm not going to repeat it again. Next comes the medical coverage. Medical coverage, here it is. Medical coverage is equals to the basic salary plus car allowance plus accommodation allowance and lastly we will be having the responsibility allowances. Okay, so all these members will be considered while calculating the medical coverage. So all these members are going to be multiplied with the medical coverage variable. So here it is, medical coverage underscore percentage is the variable that we have created, okay, in which we have the percentage. Then after medical coverage, we will be calculating the staff provident fund. So for that, I will copy the name which will be equal to okay, so here it is, which will be equal to the basic salary, car allowance, accommodation allowance, responsibility allowance, and lastly the medical coverage. Okay, and here I will close the parenthesis, and then this will be multiplied with the staff provident fund. So here I have created a staff provident fund. Okay, v underscore provident fund variable. Okay, and then semicolon. Lastly, we will be calculating the payroll tax. So our payroll tax is okay 6110. I will copy it, and then this will be equal to. So the tax will be calculated on the basic salary, car allowances, accommodation allowances, responsibility allowances, and the staff provident fund, but it does not include the medical coverage. So here I'll just copy it from here to save time. And then I will delete medical coverage from here. Instead, I will add state provident fund. Okay, this will be multiplied with the payroll tax percentage. So here I have created a variable named v underscore payroll tax. Okay, I will just click on OK, and here we can see that we've got the variable. Okay, now I'm going to validate the rule and check whether there is any error or not. So here we got this RTP value. Okay, I will then go to the variable and I will directly input the default values in it. Okay, so for car allowances we have considered according to the basic pay, it is going to be 5%. For accommodation allowance it is going to be 10%. For responsibility allowance we have seen in the requirement sheet 10%. Then in the Medicare that is going to be 15%. Provident fund is 12%, and lastly payroll tax, which is 20%. Okay, so I have given the value over here, and then now I will validate the rule, so I don't have to input the value again and again for all validation, deployment, and then launching the rule. Okay, now I have deployed it, and finally I will launch the rule here. Okay, so now I will take you to the smart view sheet. Yeah, so here is the calculation sheet. Okay, we only have the basic salaries with us. Now I'm going to create a smart view connection, and then I will calculate the rule. Okay, here we got the value. Now I will go to the variance sheet. Here we can see that there is no variance in it, hence our data is validated. So it has satisfied the conditions of the requirement. Okay, so this was our business rules, and now we will move to the last one, that is block creation. So before moving to the rule, let us have a quick introduction, or we can see a brief introduction of the uh, blocks. Okay, so for that we are taking a small example over here. In the given case you can see that we have a cube in this image. So in the cube we can see that we have a product, time, and location of MDDB. Okay, so MDDB is an application. Let us assume it consists of 4 dimensions. First is the measure, second time, third city, and fourth is the product. Okay, so we have 4 dimensions. Let us divide this into two categories. First is the sparse, and the second one is the dense dimension. So in the given case, we are assuming that measures, which is also termed as account, is our dense dimension. Then time is also our dense dimension. City, province is going to be our sparse dimension. And the product is also going to be our sparse dimension. Okay, let's see, I have made a mistake in writing the name. Okay, so here we go. Okay, so we can see that the city and product are our sparse dimension. So here we can see that we hold the data on in the combination of New York and product A dimensions. Okay, so and however we do not hold any data in New Jersey and product A combination. Fine. So it is basically termed as sparse dimension because there is no uniformity of data available to us in it. Okay. However, in case of dense dimension, as we can see here, that we have a uniformity of data as it is being systematically arranged in the cube. So here we can see the sparse dimension. So this is the summary of it. Okay, now we will see how cubes actually look like. So this is our cube. Okay, so here we have already seen in the summary sheet that New York, a combination of New York and product A have a data into it. Okay, so this is the data. Okay, in it we have data, and this these are the dense dimensions, that is sales, margin, COGS, Jan, Feb, March. Okay, and here in it we have the datas with us. So this is also called as a block. Okay, a combination of these past dimension helps us in creating a block. So here in the new, as we can see in the summary sheet, the combination of New York and product A holds data into it. So this is the block we hold in it. Then in case of Ohio, in combination with product A also holds some data. So here this is the combination that we have with us. Okay. So in the combination of sales and gen, we can see that we have data named numbered 1000. Okay, this is nothing but cells in which we are giving the inputting the values. Okay, so this was it, and I hope I'm clear till now. And this is how the cube is being created with the combination of both sparse and dense dimension. Now let us assume we do not have any we only have sparse dimension into our cube and there won't be any dense dimension. So in that case, we can see that we will be holding data like this, as we can see in this picture. Okay, so we will be holding data in the New York, in New Jersey, in Ohio, in all the combinations available to us. So this will increase the number of blocks to 12. As we have seen previously in this image that we were holding data only in these 6 blocks. First, second, third, fourth, fifth and sixth. I have already numbered it. Okay, but however, because we do not have any dense dimension in an application, we are only holding a sparse dimension, so the number of block has been increased by 6. Okay, so the total number of block have become 12, and we can see that so the index size is also is being increased to 12. Now previously we were having the block size as 12 with us, but now it has been 6. So the cube size, we can see that the cube size has been calculated by multiplying the number of blocks to each block size plus index size. So here, because we do not hold any dense dimension in an application, our in a cube, so our cube size have been increased to 84. Previously it was 78. Okay, so I can also show you the image over here. See, this is how it looks like. So there is so many number of blocks into a cube. Okay, so it becomes difficult to allocate the indexes or the addresses. If in case we can see here in the image that if we do not have any sparse dimension, instead we only hold dense dimension into an application, then it will become then the block size will be so huge. Okay, this will take the memory size will be huge then, and it will slow down the process of an application as well. So this is how our cube works, and this is all about the blocks. Now I will go to the business rule and will show you how to create a block using a business rule. So now I will right click on the rules and then click on new. Here I will name it as test underscore block size. Here I'm going to edit the script. So here I'm going to use the nested fix function. Before writing the rule, let us first go to the system view and into the database properties. Here I will select the plan 1 in vision. Okay, so here we can see that the transactions in statistics, we can see that the existing number of block here is 7194. I will right click on the plan and then I will clear all data over here. Okay, now I will click on OK and then refresh the sheet. Now we can see that the existing number of block here is 0. Now I'm going to write the business rule for creating a block. Okay, so here I'm going to consider the scenario as a best scenario. Okay, so the scenario is going to be the actual one. So before that I will first take to the version. Here I am considering the best case scenario, then comma, the entity is going to be Mexico, then again comma, the year it is going to be FY25, then we will be using end fix, and here I am going to write the formula. So here actual is going to be equal to @create block, and in parenthesis I will mention the name of the product as P292. Okay, I will or else I can do one thing, I can copy the name of the product directly from here. P292. Okay, so it is miscellaneous. Okay, now I'm going to validate the rule and then deploy it, and then finally I will launch the rule here. Okay, now let me close the database properties. Again I will go to the system view, and from there I will in action I will select database properties. Okay, now I will go to I will expand the EPM cloud, then the vision, and then finally plan 1. Here I will go to statistics and we can see that we have got the existing number of block as 1, as we have created a new block into the application. How we did that? Here we can see that a block consists of the combination of the sparse dimension, as we have already discussed with you. So here we can see that we have a combination of a sparse dimension. One member from all the sparse dimension is mentioned here. So I will open the notepad. Okay, so here we have base data as a HSP view, one HSP view, which is multiplied with the one scenario, which is best case. Sorry, one best case is the version. Okay, one version member, then we have one entity. These are all sparse dimension. I'll show you how we will be identifying it, whether it is a sparse dimension or a dense dimension. Then FY22, that is year, 1 year we have, and the another one is the scenario is actual multiplied with the product. Okay, this was also 1 in number. Okay, so this all 1 will give us a value as 1. Okay, the product of it. Hence we have got here the one number of block into database properties. Okay, now I will take you to the dimension. Here we can see that the HSP view, year, scenario, version, entity, product, market size. Market size is nothing but an attribute dimension, so we won't be considering it as a member. As we can see that the stored member property, here we can see that there is 0. Okay, so it did not occupy space in the cube, so we will just ignore the market size. We will only focus on HSP view, year, scenario, version, entity, and product. So the combination of all these dimensions forms a block. Okay, so here we have only one block created into an application. Okay, so I hope I am clear till now. For any more queries, please feel free to ask on www.bispsolutions.com. Thank you.